Have you ever just popped the hood of a car and wondered, how does all that stuff actually work? I mean, how do we get from a tank of fuel to actually moving down the road? It's a process that basically defined the modern world, and today we're going to get right into how it all works. So let's start with that big question. Seriously, what does it take to get a heavy, 2-ton machine cruising down the highway? For more than 100 years, the answer was fire. Yep, thousands of tiny, perfectly timed explosions every single minute. That was the secret sauce. But now, that's all changing. So let's go on a little journey from the fiery heart of the good old internal combustion engine to the quiet, powerful hum of the electric revolution.
Okay, so at the most basic level, traditional engines are what we call heat engines. The idea is pretty simple, right? You take the chemical energy that's locked inside fuel, you burn it to create a bunch of heat, and then you use that heat to create motion. This one concept powered pretty much the entire 20th century. Trains, factories, you name it. And of course our cars.
So, let's kick things off with the reigning champion for over a century, the internal combustion engine. This whole thing is about harnessing the power of a really fast, controlled burn.
I really want you to focus on that word explosions. This isn't a gentle, steady flame. Nope. We are talking about a series of powerful, contained blasts. This explosive force is what literally shoves the car forward. It's like taking brute force and refining it into a smooth, manageable ride.
Now, to manage all those thousands of explosions, you need an unbelievably complex and perfectly synchronized machine. Let's take a look inside what is basically a mechanical symphony.
You've got all these core parts, a piston that goes up and down, a crankshaft that turns that up and down motion into the spinning that moves the wheels, and valves that open and slam shut at exactly the right millisecond to let fuel in and exhaust out. They all have to work in perfect harmony. It's really a testament to more than 100 years of engineering. And this is the heart of it all, the 4-stroke cycle. You can think of it as a 4-step dance. First, intake. The piston moves down, sucking in a mix of air and fuel. Then, compression. The piston shoots up, squeezing that mixture super tight. Then comes the magic moment, power. A spark plug ignites it. Bang! The explosion violently shoves the piston down. And finally, exhale. The piston comes back up, pushing all the burnt gas out to get ready for the next cycle. And this whole dance happens thousands of times a minute.
And of course, there are two main flavors of this engine: petrol, which we call gasoline, and diesel. The big difference is how they get that bang. A petrol engine uses a spark plug to set things off. A diesel engine, though, it does things differently. It uses pure pressure. It squeezes the air so much that it gets ridiculously hot, and then it just injects the fuel, which explodes instantly without any spark. This high compression is why diesel engines have so much torque, so much grunt, making them perfect for big trucks and heavy equipment.
But that entire symphony of explosions and moving parts, well, it's now facing a really serious challenger. So let's shift gears, pun intended, and dive into the rise of electric power, a whole new chapter for the car.
And here's something that might surprise you. Electric cars are not some brand new futuristic invention. They were actually some of the very first cars ever made, competing right alongside gasoline vehicles more than 100 years ago. Back in the day, EVs were actually pretty popular, but gasoline engines got more powerful and cheaper, especially around the World Wars, and electric cars just kind of faded out. After a few failed comeback attempts, it was really the growing concerns about emissions in the 90s that brought them back into the spotlight. But the real game changer? That was the recent breakthroughs in battery technology that finally made EVs a practical choice for everyday people. Okay, now remember that long list of parts for the combustion engine? Compare it to this. An electric vehicle is just so much simpler, mechanically speaking. You have a big battery pack, an electric motor that turns the wheels, and some electronics to manage everything. That's about it. Way fewer moving parts means more than just simplicity. It means a completely different kind of reliability and performance.
So we have the old guard and the new challenger. Let's put them side by side and see how they really stack up on the things that matter, like efficiency, performance, and just day-to-day living.
This really nails the core difference. A combustion engine has this multi-step process: chemical energy to heat, then heat to motion. And you lose a lot of energy along the way. The EV, on the other hand, is beautifully direct. It takes stored electricity and converts it straight into motion. So much cleaner.
And that difference in process leads to this. I mean, this is a staggering difference in efficiency.
In your typical gas-powered car, only about a quarter of the energy from the fuel actually goes to moving you forward. The rest is just wasted, mostly as heat. In an EV, that number is closer to 85%. That is a massive leap in how effectively we use energy.
So what does all this feel like for the driver? Well, that instant torque in an EV gives you that wild, push-you-back-in-your-seat acceleration right from a stop. An electric motor gives you all its power immediately. Maintenance is way simpler, no oil changes, no spark plugs to worry about. The big trade-off, of course, is refueling. It takes longer, but in return, you get zero tailpipe emissions.
Now, this big shift from combustion to electric, it's not happening overnight. There's a middle ground, and the future is still being written, mostly in the chemistry labs working on batteries.
And that middle ground is the hybrid. These vehicles are like a bridge. They combine a gas engine with an electric motor. They're smart enough to capture energy when you brake and use that little electric motor to help out, which makes them way more fuel efficient while still giving you the convenience of a regular gas car.
But ultimately, the entire future of the car really hinges on the battery. That's the whole ballgame. The race is on to pack more energy into smaller, safer batteries. Things like solid-state tech, to give us more range and to cut down those charging times. And just as important, we have to figure out how to sustainably recycle and reuse these batteries when they're done.
So, from the controlled fire of the combustion engine to the silent power of the electric motor, the evolution has been absolutely incredible. The question really isn't if things are going to keep changing, but how, and what amazing technology is going to win the race to power all of our journeys into the future.